Designing a custom QAOps platform, whether it is a reporting engine or an AI-driven test service, requires a robust architecture. When your stack includes a FastAPI backend, a database, and Kafka, you are managing a high-throughput system that must be as resilient as the production environment it validates. The infrastructure decision usually involves a choice between static virtual machines on EC2 or vSphere and container orchestration via Kubernetes. Deploying with Docker Compose on EC2 is a common starting point, but it fails at scale. Static VMs lack the native orchestration required to handle the horizontal scaling of FastAPI workers or the persistent volume management. This architectural pattern results in non-deterministic infrastructure. When the test harness reaches resource saturation, it produces false negative signals that degrade confidence in the results. Kubernetes, managed via Helm, is the technical standard for this architecture. By utilizing Helm charts, you codify the entire QA lifecycle as infrastructure as code. This allows you to manage Kafka as a distributed cluster, utilize stateful sets for your database layer, and leverage horizontal pod autoscalers to handle resource-heavy tasks. However, a critical mistake often made is collocating this QA infrastructure within the same Kubernetes cluster as the application being tested. From a systems engineering perspective, this is a major reliability risk. First, consider the blast radius. Integration testing often involves generating massive gRPC loads or querying Kafka topics at high frequency. If these QA services reside in the same cluster, they compete for the same CPU cycles and network bandwidth as the application. Without airtight resource quotas, a spike in your QA logic can trigger node pressure and evict critical application pods, leading to false positives in your test results. Second, sharing a Kafka broker introduces event pollution. Your QA solution should treat the target system as an isolated entity. If your test harness and the application share the same message bus, you lose the isolation needed for accurate metrics. For those concerned with cost or cluster overhead, the professional alternative is the use of ephemeral clusters within the CI/CD pipeline if you don't need persistence infrastructure. Using Jenkins or similar orchestrators, you can provision a lightweight, isolated Kubernetes environment for the duration of a test suite. This provides the perfect sandbox for chaos testing. You can safely perform fault injection, simulate network partitions, or trigger node drains to see how the application recovers, all without risking the stability of a shared staging or production cluster. But what about components that require persistent, high availability? Services like a centralized reporting dashboard or a historical trend analysis engine cannot be ephemeral. There is often a temptation to deploy this into the same cluster where the application system is running to minimize cross-cluster overhead. Technically, this is a mistake. Persistent QA services should ideally reside in a dedicated management cluster. This ensures your quality infra is live even when the other clusters are completely down. However, if an entirely separate management cluster is not an option due to budget or organizational constraints, you must implement strict logical isolation. In this scenario, your persistent QA services must be isolated within a dedicated namespace protected by rigid resource quotas and limit ranges. You must also apply network policies to prevent cross-namespace traffic from interfering with the application's internal communication. While this is less secure, it prevents your reporting and telemetry tools from messing with the rest of the system. In summary, avoid the convenience of shared, unprotected infrastructure. Whether using a dedicated cluster, ephemeral Jenkins-driven environments, or strictly governed namespaces, prioritize isolation with logical peering. Treat your QA ops services with the same architectural rigor you expect from the code they are testing. Clean signals require clean environments.